Good morning, good afternoon, good evening, and welcome back to part 2 of the application of Calculus 2 differentiation. We are now going to be answering question 7.1.3 and question 7.1.4, and in keeping with our naming convention, this is the application of Calculus 2 differentiation part 2. So we have already shown that A is equal to -1 and B is equal to 3 as required. Therefore, the cubic function fx is equal to y is equal to, our A is -1, so this is minus x cubed, and our B is equal to 3 plus 3x plus 2. And we are required by question 7.1.3 to determine the coordinates of B at turning point of F. That is B there, and when they say it's a turning point, you can see it is a turning point. And at the turning point, the gradient at that turning point is 0. And for us to get the gradient of B, given the cubic function, we differentiate the cubic function in order to get the gradient. That is where the application of differentiation comes into play in this question. So, let us differentiate our cubic function with respect to x. We have dy dx is equal to, differentiation is basically multiplied by the power and reduce the power by 1. So our dy dx is equal to minus 3x squared plus 3, and our constant goes to 0. So this is equal to gradient of fx at any point on the function, because that will be determined by the value of x at that point. So at point B, we know that the gradient is 0 because it is a turning point. Therefore, we have 3 minus 3x squared plus 3 is equal to 0, and we have divide both sides by minus 3, we get x squared minus 1 is equal to 0. And therefore, by factorizing the difference of two squares, which is x squared minus 1, we have x minus 1 multiplied by x plus 1 is equal to 0. Therefore, x is equal to 1, or x is equal to minus 1. And looking at where B is, x cannot be minus 1, so therefore the x coordinate of B is equal to 1. So then, using the cubic function, with x equals to 1 we have y equals to minus bracket 1 to the power 3. Notice that the minus does not include the 1. It's a minus 1 which stands alone, and the x which stands alone, so our x is 1. Don't put the minus in the bracket, and if you have a square there, you might end up with the wrong result. So it's a minus bracket 1 to the power 3 plus 3 bracket 1 plus 2. That gives us y is equal to minus 1 plus 3 plus 2, which is equal to 4. And therefore, the coordinates of B are x is 1 and y is 4, and that's the solution to that question. And that question was 4 marks. Not very difficult, but fairly difficult. The next question is perhaps more challenging, and it says 7.1.4, show that AB is parallel to the x-axis. So in other words, we need to find the coordinates of A, and if the y coordinate of A is equal to 4, then we know that the line that joins A to B is indeed parallel to the x-axis, because the gradient of that line will be 0 and the gradient of the x-axis is 0. So for us to find the coordinates of A, we notice that at point A, it is a point of intersection of the cubic function and the line. So in other words, the coordinates of A satisfies both the line and the cubic function. So 7.1.4, we have cubic function y is equal to minus x cubed plus 3x plus 2, and our line y is equal to minus x plus 2. If this is your equation 1, this is your equation 2, then at A we have equation 1 is equal to equation 2, and therefore we have minus x cubed plus 3x plus 2 is equal to minus x plus 2. Then let's take everything to the right hand side. So we will have x cubed minus 3x minus x plus 2 minus 2 is equal to 0. And then we have x cubed minus 4x plus 2 minus 2 is 0 is equal to 0. So if you notice here, we have x cubed minus 4x is equal to 0. And at the top here we had the 3x minus 3x squared plus 3 is equal to 0, and we divide it throughout by 3 minus 3 in order to get x squared minus 1. Here you can't divide by x, because if you do that you will lose a solution. X is equal to 0 is a solution to this equation. So if you divide by x, you will lose that solution. In order to avoid that, we factorize first x out, and we have x squared minus 4x is equal to 0. And we factorize further, so we have x bracket, this is a difference of two squares, x squared minus 4x, so we have x minus 2 bracket bracket x plus 2 all is equal to 0, and therefore we have x is equal to 0, or x is equal to 2, or x is equal to minus 2. If we look at the point A, where it is located here on the graph, we can see that x cannot be 0 there, and x cannot be 2 there, so therefore x is minus 2. Therefore, the x coordinate of A is minus 2, and using this with equation 2, we have y is equal to minus bracket minus 2 plus 2, which is equal to 2 plus 2 and equals to 4. Therefore, the coordinates of A are x is minus 2 and y is 4. So in other words, if you draw a line from A to B, it passes through 4 and gets to B, and you can further show that the gradient of AB equals 2 if we take the y coordinates of point B and point A. If we start with the point A, we have 4 minus 4, and the x coordinate of point A is minus 2 minus 1 for B, which is equal to 0 over minus 3, and this is equal to 0. So in other words, the gradient of AB is 0. So we can say the gradient of AB equals to 0, and therefore AB is indeed parallel to the x-axis, as we have been required to show. So part 2 is done. We have answered question 7.1.3 and 7.1.4. And those are 9 marks. Probably the 2 of them were the most challenging. And then in the next part 3, we will be looking at question 7.1.5 and 7.1.6. Thank you.